Today, I will do a demonstration to show you how to use KLA-Tencor P6 stylus profiler. I will use a piece of silicon wafer with some metal deposition to demonstrate you the standard procedure. Okay, the first step is put this sample inside the machine, the chamber. I want you to pay attention, notice this area. That area is where the feature is, okay? So we want to make sure this area, the interested area, sit at the center of the sample holder. Like that. Then we need to close the door. Now, let's look at the interface, the software interface. You see, if I move the mouse, you will see, there's a mouse here. They are crossed into this area. So you will see the blue dot here. The blue dot is the center of the sample holder. That's where I want you to put the interest area on that center. Because once you put the interest area at that center, you can see roughly where it is. So first step is menu load. On this menu is a man load. Actually, it's a menu load. If you click that, you will see the blue dot goes to the center. What that means is the sample holder sits on a stage. That stage moves to put the interest area underneath the stylus. That's what happened. So once the interest area is sitting under the stylus, you can use focus. Click focus. It will automatically bring the sample to the stylus and also focus the camera on the interested area. So you can see as the sample is bringing close to the stylus, also we focused. So you can see the features here. So there's a reminder here is you always use focus to bring the sample to the stylus. Here we tell you not use up and down buttons here. Okay. You should not use those buttons. Focus is the only button to bring the sample to the stylus. Okay. So here has three buttons here, like slow, medium, fast. That is the stage moving speed. Okay. Normally we use medium. We don't want the stage move too fast or too slow. We just use medium. So those arrows up and down, left and right, moves the stage. For example, if you can see what happened is actually this left arrow button move the stage to the left. Okay, right button move the stage to the right. Yeah, you can see the movement. Up button, up, so you can see the stage move up. And the stage also move down. Okay. Now let's talk about how to make a measurement. So first step is decide what recipe to run. Let's close this window for now. Okay. So once we close that window, we come to here. It says Profiler Recipe Editor, General Mid-Range. What's that? Okay. To explain that, we will close this window too. This brings us to the Profiler Catalog window. Okay. I need to remind you and also warn you, do not click here. Do not close this window. If you click this window, you shut down the software. Okay. So the software open need a password. Okay. So don't shut down the software. So if you get back to this kind of a, you can call it a catalog window, or you can say it's home window. Okay. So you can find the scan recipe here. If you click scan recipe here, there are different recipes. Normally, we ask you to use general use recipes, right? And general mid-range recipe. That's the recipe we used. Okay. So let's click the name. Will bring you the parameters, the settings of that recipe. Okay. So in our case, we have a hard material, silicon wafer with oxide. On top of that is metal. So in this recipe, we look at the stylus applied force. This is the first thing you need to decide. Because this sample we are using today, it's a hard material. Okay, so we are using 2 milligram. The force we apply is 2 milligram. For example, if you come from a different research, you may use polymers, you may have a photoresist on your hard substrate. In that kind of soft substrate material, we require you to use 0.5 milligram. The reason is if you apply a lot of force at the tip of the stylus, it may penetrate your film. That will, make the measurement sometimes impossible. Okay? So we don't want a penetration. But in this case, because we are hard material, we prefer to use a larger force. The reason is the larger the force, the smaller the noise. Otherwise, if you use small force, sometimes the measurement noise will impact your results. Okay? That's the first thing you need to think about when you use this machine, force. The second very important thing you need to think about is the range and the resolution. So when you bring in the sample, you should have some rough idea what's the feature. Okay. There are different type of feature. In this machine, we define those feature profile like this. So you can have up and down, or sometimes you can say the peak and the valley. That's one profile. That's the profile when you choose the highest sensitivity or highest resolution. Or if your feature is very big, you use this, there's a consequence. For example, if the feature, the peaks and the valleys is very large, so the maximum height of the peak minus the negative value of the lowest valley, if that difference, the range, is bigger than 30 micron, then it will not measure correctly. Okay. For this profile specifically, because the profile shows peaks and valleys, if you have any peak above 6.5 micron, it's just show you a straight line. If you have any valley that is, below this zero line, more than 6.5 micron, it's also show you a straight line. So that's saturated. The signal is saturated. So with that said, if you choose a bigger range, okay, 65 micron range, you still use this peak and valley profile. So that will measure the maximum peak is 65 divided by 2, which is 32.5 micron. That can measure much bigger peak. Same thing when you measure the valley, right? There's a trick here. If you choose the largest range, okay, this is very important because for some the microfluidics materials, the substrates, they don't have peaks and valleys, right? They have valleys or peaks sometimes, So if you choose this profile, valley only, so that on that substrate, you can measure the trenches or vias as deep as 327 micron. So when you bring in your sample, think about what kind of profile you have. You have a valley only, or you have a peak only, or you have ups and downs. Okay, then if you choose lower range, then there's only one profile. Okay, that's that. Another thing I want you to pay attention to is scan speed. Normally, we don't recommend very high speed. Normally, you can do 20. So 20 micron per second scan speed and the sampling rate is 20 hertz. What that mean? So that means every second there is a 20 micron movement, okay, under the tip. And if you sample 20 times within 1 second, that means every micron movement you have a data point. So that actually decides your lateral resolution. Okay, how many data points you have. Okay, if you care about lateral resolution, so you need to think about this setting. Okay, so don't scan too fast and think about the lateral resolution. There are some other things you need to consider. For example, if you have a much bigger feature, don't scan fast, slow down, because if you have a bigger feature, if you cross a bigger feature, you go too fast, then you don't get the profile right? You're leaving this feature and you land somewhere, kind of far away, right? So you lose your resolution. Another thing, don't scan too fast, is if you scan too fast for big features, especially those with peaks and valleys and those kind of things, you may damage the tip. You cause the tip collide with your feature. If you do that very fast, the force could be very large. Okay? So with that said, if your feature is very smooth and it's not, it's easier to scan faster, okay?